Look at the structure as it continuously expands and reconfigures itself. This is exactly how modern AI operates. It learns from new data, changes behavior over time, and executes workflows without human intervention. The old model of building a static system and bolting security controls on at the end cannot secure something that is constantly evolving. Governance, risk, and compliance teams typically rely on predictable cycles. They document a policy, test the controls, and run a periodic audit using a static checklist. But when an autonomous system drifts out of alignment in a matter of weeks, that quarterly audit is blind to the actual risk exposure. To manage that continuous risk, we have to build an AI-native governance framework. This requires embedding real-time monitoring directly into the engineering pipeline, setting strict permission boundaries, and building runtime intervention mechanisms to stop rogue agent actions. Moving away from periodic checks to real-time verification is the only way to close the assurance gap. It gives you mathematical proof that your controls are working right now, allowing you to maintain authority over autonomous technology. Step 1 in this framework requires looking upstream. Before a model deploys, you must map its entire supply chain to uncover exactly where vulnerabilities center. Sending a standard security questionnaire to a software vendor is insufficient. The risks in artificial intelligence systems sit deeper, buried inside open-source code libraries, or directly encoded into the massive datasets used for training. You need to track every external dependency. This includes the specific third-party APIs your system will call, and the pre-trained foundational models it relies on to process information. We use an AI bill of materials, or ABOM, creating a structural inventory linking your model to every dataset and API. Green check marks verify component lineage. We apply cryptographic provenance, a digital signature proving data authenticity. This verified inventory eliminates guesswork, letting you trace vulnerabilities instantly. Without that strict inventory and cryptographic proof, you cannot know what you are running. Any governance policies you enforce later in the deployment cycle are built on a functionally blind foundation. Once the model is verified and deployed, its accuracy will degrade. This is known as model drift, and it is an inevitable result of operating in a live environment. A static checklist from a previous audit cannot catch this degradation. You have to implement AI-native continuous telemetry to measure the system's performance at all times. If a fraud detection model encounters new, evolving customer behaviors, its accuracy will drop. You need to detect that drop the exact moment it happens, not 3 months later during a review. On this live telemetry dashboard, setting strict performance thresholds automatically triggers a logged alert the second accuracy dips below the red line. This system-generated evidence creates an immutable record, proving exactly when controls were enforced. Relying on out-of-date manual reports is compliance theater. Automated telemetry replaces assumed safety with real-time mathematical proof. Monitoring a passive model is only part of the equation. Active agents introduce severe behavioral risks because they can take action, call external systems, and chain APIs in unintended ways. To govern behavior, we assign the agent an identity and apply least privilege. In this interface, we strip away full access, locking the agent to a restricted read-only API connection. This scopes permissions, restricting decision authority to exact approved boundaries. When you treat an autonomous agent with the exact same strict role-based limitations as a human employee, you isolate the system. Now we have our framework in place. Mapped upstream dependencies into verified AI bombs, instituted telemetry for real-time dress detection, scoped agent permissions using least privilege, and wired a functional kill switch. When these interconnected steps are built into your pipeline, compliance stops being a manual scramble at the end of the quarter. It becomes a continuous, natural byproduct of the system's engineering. Look at how this interlocking structure adapts to external forces without breaking. That is the outcome of AI-native security. Your systems move past merely passing static audits. They become verifiably and operationally trustworthy. Take this exact AI-native framework and start applying it to your high-risk internal use cases, like your HR and finance models. With proper continuous governance built into the pipeline, the business deploys autonomous technology with absolute confidence.